Welcome to This Explainer. I'm taking 15 years of my classroom experience and boiling it down into your ultimate study guide for those rigorous algebra exams. Whether you're prepping for a high-stakes standardized test or honestly just trying to survive your next math quiz, you are exactly where you need to be.
Look, quadratics can be tricky. They can definitely be stressful, but practice really is key here. Taking your time, writing out each step, double-checking your work, it makes all the difference. By explicitly highlighting the arithmetic traps that cost students marks every single year, we're going to build your confidence today. You see, the difference between an average score and a top-tier grade isn't just about knowing the formulas. It's about knowing exactly where the invisible pitfalls are hiding. Okay, let's quickly look at our roadmap for tackling those IB, DP, or IGCSE questions. 1. Solving methods and shortcuts. 2. Unlocking the discriminant. 3. Navigating the quadratic formula. 4. Completing the square safely. 5. Sketching flawless parabolas. And 6. Real-world projectile applications. Let's dive right in.
Part 1. Solving methods and shortcuts and avoiding those early traps. We'll start with factoring, which is usually the fastest method, provided you dodge some incredibly common pitfalls. When you see a quadratic, your brain should immediately ask, hey, can I just factor this easily? Because, let me tell you, factoring has some major danger zones. I literally see students lose marks every single year because they miss the greatest common factor first, choose the incorrect factor pairs, or just completely forget to set each factor to 0. You absolutely have to verify that your factor pairs actually add up to B and multiply to C. And please, don't dive straight into complex factoring if there's a simple greatest common factor just staring right at you. Always check for that first. And finally, don't stop at finding the factors. Remember, you have to set each one to 0 to find your actual solutions. Here's a huge teacher tip for you. Always verify your factors by expanding them back out. It takes, maybe 5 seconds? But taking those 5 seconds to expand it back out is going to immediately catch any silly errors and guarantee your accuracy. Seriously, it's a built-in safety net. If it doesn't match your original equation, boom, you know exactly where to fix it before the examiner ever even sees it. Also, keep an eye out for shortcuts. Before you jump into some massive formula, check for special quadratic cases, because they can be solved in a fraction of the time. Missing your linear term, where b equals 0? Just isolate the x squared and take the square root. Just, don't forget your plus and minus signs. And if you're missing the constant, so c equals 0, simply pull an x out to the front. You'll literally have your answers in 10 seconds flat. Moving on to part 2, unlocking the discriminant, guiding your solving strategy. Now, what's really fascinating about this concept is that it acts almost like a crystal ball for your equation. It's that little piece of the quadratic formula hiding right under the square root symbol, b squared minus 4ac. Calculating this discriminant first is a massive time saver because it tells you exactly how many and what type of solutions to expect. If it's a positive number, you've got 2 real solutions. If it hits exactly 0, the parabola just perfectly kisses the x-axis, giving you 1 real solution, a double root. And if it's negative, well, that leads us right into our next concept. If it's negative, you get 2 complex solutions. I really want to demystify this right here, right now. Getting a negative number under the square root does not just mean no solution. It means no real solution. And that is a perfectly valid and expected mathematical answer. It simply means the parabola never crosses the x-axis. As you move into more advanced IB or DP courses, you'll learn a lot more about these complex roots. But for now, just don't panic if your discriminant turns out negative. All right, part 3, navigating the quadratic formula and defeating sign errors. When factoring fails, the quadratic formula is your reliable, all-purpose heavy hitter. But man, it is an absolute minefield for sign errors. You have to handle it with extreme care. Let me show you the absolute #1 trap I see, incorrectly squaring a negative b. So always use parentheses when you're substituting values. A negative times a negative is a positive. The wrong way is writing -7 squared equals -49. The right way is putting that -7 in parentheses, which gives you a positive 49. If you just punch -7 squared in your calculator without those parentheses, it's going to tell you -49, and your entire problem will just completely fall apart. Write it out explicitly. Which brings us to part 4, completing the square safely, step-by-step mastery. Completing the square is a heavy lifter that requires really careful, explicit algebraic steps so you don't accidentally drop any terms along the way.
You're essentially forcing a quadratic equation into a perfect square trinomial format. Step 1, move the constant term to the right side. Step 2, explicitly half the b term and square it. And step 3, add this new constant to both sides. That last part is critical. I've seen hundreds of exams where a student brilliantly calculates that new constant, but then only adds it to the left side. It's a tragic mistake. Balance the equation every single time. Here are a few diverse equations for a dedicated practice session. We've got x squared plus 6x plus 8 equals 0, x squared minus 12x plus 11 equals 0, and 2x squared minus 5x plus 67 equals 0. The first two are pretty straightforward, right? Because the a term is just 1 and the b terms are nice, even numbers. But that last one? Oh, that one is going to challenge you with fractions and a leading coefficient. Tackle that one when you're feeling brave, and keep a really sharp eye out for incorrect halving or arithmetic traps when moving those terms. Part 5. Sketching flawless parabolas, making the math visual. Let's pivot slightly to the visual side of quadratics and see how everything we've just learned actually builds a beautiful graph on the coordinate plane. Think about the parent function, y equals x squared. It's the simplest parabola. You can quickly sketch any parabola just by pretending the vertex is your starting point and then using the a value to vertically stretch that parent function. Normally, from the vertex, you go over 1 and up 1, but if your a value is 3, you go over 1 and up 3. It is an incredibly fast way to plot points without relying on a tedious, massive table of values. You also need your anchors. Use the vertex, where x equals negative b over 2a, as the center. Then use the y-intercept, which is just c, as a really quick accuracy check. Identifying that y-intercept is a zero-effort way to create a checkpoint on your graph, guaranteeing your parabola is opening and positioned correctly. Think about it. If you plug in 0 for x, the first two terms vanish, leaving just your c value. If your vertex calculation puts the parabola up in quadrant 1, but your c value is negative 20, boom, you immediately know you made a calculation error. All right, final section, part 6, real-world projectile applications, grounding math in reality. Let's see what happens when we apply these tools to a real-world physics scenario, like throwing a ball straight up into the air. This is where quadratics step right out of the textbook. Let's look at the equation. H equals negative 5t squared plus 14t plus 3. Every single coefficient here tells a story. Our starting height is 3 meters. That's the c term, exactly where the object starts. Our initial velocity is 14 meters per second. That's the b term, how hard you threw it. And that negative 5 in the front, that's the a term, representing the unavoidable force of gravity, pulling it right back down to Earth. So by calculating the vertex using negative b over 2a, we get exactly 1.4 seconds. That instantly determines that the ball reaches its absolute highest point 1.4 seconds after it leaves the hand. This is exactly why knowing how to find the axis of symmetry is so incredibly powerful. It doesn't just help you draw a curve, it tells you exactly when a projectile maxes out its journey in the real world. As we wrap up this explainer, I want to leave you with a question to chew on. Which method would you personally choose for an IGCSE level problem like 3x squared minus 5x minus 2 equals 0? Based on the flowchart of strategies we covered today, what is your safest, most efficient first move? Because your leading coefficient isn't a 1, completing the square might get a little messy. Factoring is definitely possible, but do those factors jump out at you quickly? If not, remember, the quadratic formula is always waiting right there to carry you across the finish line. Master these decisions, steer clear of those arithmetic traps, and you are absolutely going to crush your next algebra exam. Keep practicing, and I'll catch you next time.